History remembers Edmund Halley for a comet, but if that is all you know of him, then history has deceived you. He was not merely the namesake of a streak of ice and dust across the heavens. He was the man who carried Isaac Newton's masterpiece to the world, who dared to map the stars of the uncharted southern skies, who wrestled with the invisible grip of Earth's magnetism, and who tried to predict the movements of the very air we breathe. Halley was no shadow figure in Newton's orbit. He was a blazing mind of his own. And yet, how strange it is that his name shines only once every 76 years, while his life, a tale of relentless discovery, remains almost forgotten. The story begins in Haggerston, London, where Edmund Halley was born on the 8th of November, 1656, into a world of both turmoil and possibility. England in the mid-17th century was a nation divided. The English Civil War had left scars on society, and the Great Fire of London was still in the future. Yet, amid this uncertainty, Halley's family had the stability of wealth. His father, Edmund Halley Sr., was a prosperous soap maker, a man who had risen to relative affluence. This fortune would prove vital. It gave young Edmund something most aspiring scholars of his age lacked: the freedom to pursue knowledge for its own sake. As a child, Halley showed unusual curiosity. While other boys of his age amused themselves with games, he was fascinated by the workings of clocks, compasses, and the stars overhead. England, at this time, was still on the cusp of modern science. The telescope had been invented barely half a century earlier. Galileo's starry messenger was still a recent echo. Kepler's laws had only just begun to be understood. Yet here was a boy in London, staring at the sky, already dreaming of his place in this unfolding revolution. By the time he was a teenager, Halley was well versed in mathematics and astronomy. His education prepared him for something extraordinary. In 1673, at the age of 17, he entered Queen's College, Oxford. There he was surrounded by scholars and thinkers who were pushing the boundaries of human knowledge. Oxford in the 1672nd was alive with debate. The ideas of Francis Bacon, with his insistence on experiment and observation, had taken root. The newly founded Royal Society was already transforming the way science was practiced: less philosophy, more evidence. Halley, a student with both money and curiosity, found himself in the right place at the right time. At Oxford, Halley did not limit himself to lectures and books. He purchased instruments, quadrants, sextants, telescopes, sometimes at great personal expense. He began to chart the positions of the stars, recording them with painstaking precision. By 1676, he had gained such a reputation that he was compared to Tycho Brahe, the great Danish astronomer who had charted the northern skies decades earlier. But Halley knew that Brahe's work, and indeed all European astronomy, had one gaping hole. The southern hemisphere was still largely uncharted. To map those stars would require courage and vision. And so, at the astonishing age of 20, Halley made a decision that would shape his legacy. He would sail to the South Atlantic. The year was 1676 when Halley secured passage aboard an East India Company ship bound for the island of St. Helena, a remote speck in the Atlantic Ocean between Africa and South America. Why St. Helena? Because it lay far south of Europe, making it one of the few accessible places from which the southern constellations could be observed with clarity. The voyage itself was no small undertaking. Sea travel in the 17th century was dangerous. Storms, pirates, and disease were constant threats. But Halley was undeterred. Armed with his instruments, he set off to do what no Englishman had done before: to map the stars of the southern hemisphere with the same rigor applied to the northern skies. At St. Helena, Halley worked tirelessly. Night after night he observed, charted, and calculated. He endured the island's difficult climate, its humidity, its heavy rains, but he persevered. By 1678, he had cataloged the positions of 341 southern stars. This was a monumental achievement. When he returned to England, his work earned him the nickname the Southern Tycho, after Tycho Brahe. Even more remarkably, he was only 22 years old. The Royal Society, impressed by his results, welcomed him as one of their own. When Edmund Halley returned from St. Helena in 1678, he did not come back as a mere student or amateur enthusiast. He came back as an astronomer of international reputation. His catalogue of southern stars was nothing short of revolutionary. For the first time in history, Europe had a scientific map of the southern skies, a mirror to the northern constellations that Tycho Brahe had charted. The Royal Society wasted no time. At just 22 years old, Halley was elected as a Fellow. This was a rare honor, an acknowledgment that he had already made contributions to astronomy on a global scale. In that same year, King Charles II granted him a Master of Arts degree from Oxford, bypassing the usual requirements. The king had recognized, as did the scholars of the age, that Halley was destined for greatness. But the story of Edmund Halley cannot be told without weaving it into the greater narrative of the scientific revolution. The late 17th century was a time of radical change. Old Aristotelian worldviews were collapsing. The telescope had opened new heavens. Galileo Galilei had shown the moons of Jupiter, Johannes Kepler had discovered the laws of planetary motion, and René Descartes had filled Europe with bold new philosophies of motion and matter. Yet, one great puzzle remained unsolved. What force governed the movement of the planets? It was into this puzzle that Edmund Halley would throw himself not alone, but alongside another genius, one whose name would forever be paired with his own, Isaac Newton. The friendship between Edmund Halley and Isaac Newton is one of the most important partnerships in the history of science. Without Halley, Newton's Principia Mathematica, arguably the most important scientific book ever written, might never have been published. The story begins in 1684, when Halley visited Cambridge to speak with Newton about celestial mechanics. Halley and other members of the Royal Society, including Robert Hooke and Christopher Wren, had been debating the problem of planetary motion. Everyone knew that Kepler's laws described how planets moved, but no one could explain why they moved that way. Hooke boasted that he had the answer, but he could not produce a mathematical proof. Halley, searching for clarity, traveled to Newton. He asked him directly, what path would a planet follow if it were attracted to the sun by a force inversely proportional to the square of its distance? Newton's response was astonishing. He told Halley that he had already solved that very problem years earlier, and that the orbit would be an ellipse. Newton even claimed he had written a proof of it, though he could not find the paper. Halley pressed him to work it out again. Encouraged, Newton began to write. Over the next 2 years, Halley stayed in contact with him, urging him on, encouraging him to expand his ideas. The result was Philosophiae Naturalis Principia Mathematica, the Mathematical Principles of Natural Philosophy, published in 1687. But here is the crucial detail. The Royal Society had run out of funds and could not pay for the book's publication. It was Edmund Halley, not Newton, who paid out of his own pocket to ensure the work saw the light of day. Halley even handled the editing, correspondence, and typesetting, despite the fact that Newton's book was dense, technical, and sometimes combative, especially in its attacks on Hooke. Halley endured these challenges with patience because he believed, correctly, that Newton's work would change the world. When the Principia was finally published, it laid down the law of universal gravitation and the 3 laws of motion. It unified the heavens and the earth under one framework. It was the birth of modern physics. And it was possible only because Edmund Halley stood behind Newton as a supporter, financier, and friend. In this act alone, Halley secured his place in history, but his own discoveries were far from over. Halley's greatest personal triumph would come from a celestial visitor that had fascinated humankind for centuries, the comet. Throughout history, Comets were seen as omens, signs of disaster or divine wrath. They appeared suddenly, streaking across the heavens, and then vanished, sometimes for generations. No one knew what they were, or whether they ever returned. Halley, studying the historical records of comets, noticed something curious. The comets of 1,531, 1,607, and 1,682 all followed very similar paths. Could it be, he wondered, that these were not three different comets, but one and the same, returning on a cycle? Using Newton's laws of motion and gravitation, Halley calculated the orbit. His conclusion was bold. The comet seen in 1682 was the same as those in 1531 and 1607. What's more, he predicted that it would return again around 1758. This was a daring claim. Halley himself admitted that he would not live to see it verified, but he was right. In December 1758, 16 years after his death, the comet returned, exactly as Halley had predicted. The comet was named in his honor, Halley's Comet. For the first time, a comet was shown to be not a random apparition, but a celestial body bound by the same laws as the planets. Halley had brought order to what had once been a mystery of the heavens. Though the comet immortalized his name, Halley's intellect roamed far beyond astronomy. He was a man of boundless curiosity, and his work touched on nearly every branch of science, geophysics and magnetism. Halley studied Earth's magnetic field and even suggested that Earth might be hollow with concentric spheres inside it. Though wrong, the idea showed his willingness to think boldly. Meteorology. He investigated the trade winds and monsoons, linking them to solar heating, a major step toward modern climate science. Demography and actuarial science. Halley compiled one of the first life tables showing the statistical probability of death at different ages. This would later become the foundation of life insurance. Cartography and navigation. Halley conducted surveys of the Atlantic, improving navigation for sailors. Few men in history have been so wide-ranging. Where Newton was a focused genius, Halley was an explorer, venturing across disciplines with fearless imagination. By the dawn of the 18th century, Edmund Halley had already lived a life of adventure and discovery. He had mapped the southern stars, championed Newton's Principia, and predicted the return of a comet that would one day bear his name. Yet his career was far from over. In the early 1702nd, Halley's attention turned increasingly toward applied science problems that blended theory with practical use. One of his greatest passions was navigation, a subject of immense importance to Britain's growing maritime empire. The accuracy of a ship's position at sea depended on reliable charts, and Halley set out to improve them. In 1698, he obtained command of a small naval vessel, the Paramour, with orders to conduct a magnetic survey of the Atlantic Ocean. Halley was not a naval officer by training, but his reputation as a scientist convinced the Admiralty to entrust him with the mission. This was unusual, even radical. Here was a scholar, not a sailor, given charge of a ship and crew. Halley sailed twice into the Atlantic, braving storms and tensions with mutinous officers to chart variations in Earth's magnetic field. His voyages produced the first isogonic chart, a map showing lines of equal magnetic variation. This was a breakthrough for navigation, giving sailors a new tool to steer more accurately across the seas. It was a remarkable example of Halley's career-long pattern, identifying a practical problem, applying scientific reasoning, and producing a solution that advanced both theory and practice. Not all of Halley's ideas were correct, but even his mistakes were bold and imaginative. One of his most curious theories was the hollow Earth hypothesis. In a paper presented to the Royal Society in 1692, Halley proposed that the Earth might consist of a hollow shell about 500 miles thick, containing two inner concentric shells and a solid core. These shells, he speculated, might each have their own magnetic poles, which could help explain the strange variations observed in Earth's magnetic field. Even more provocatively, Halley suggested that the inner regions might be habitable, perhaps even populated. He theorized that light from the atmosphere could reach inside through auroral openings at the poles. Modern science has, of course, rejected this hypothesis, but Halley's proposal illustrates his intellectual daring. He was unafraid to put forward bold conjectures in the pursuit of understanding, even if those conjectures later proved wrong. And in doing so, he inspired future generations to ask bigger questions. Halley also turned his attention skyward, not to the stars this time, but to the winds and weather of Earth. In 1686, he published a pioneering study of trade winds and monsoons. Sailors had long known of these patterns, but Halley was among the first to offer a scientific explanation. He linked them to solar heating, recognizing that the sun's warmth created pressure differences in the atmosphere that drove large-scale wind systems. This was a significant step toward the science of meteorology. In his maps, Halley sketched the circulation of winds across the globe. His vision was not perfect. He lacked the modern knowledge of Coriolis forces, but it was an impressive attempt to explain planetary-scale weather. It showed again his instinct to connect cosmic order and earthly phenomena, seeking unity in the forces of nature. Perhaps less glamorous, but equally important, was Halley's work in demography. In 1693, he published an analysis of mortality rates using data from the city of Breslau in modern Poland. From these records, Halley constructed one of the first life tables, calculating the probability that a person at a given age would live to a certain age. This was not only groundbreaking science, it was the birth of actuarial mathematics, the foundation of life insurance. Halley probably did not foresee the vast financial industry his work would one day sustain, but his innovation once again showed his versatility. Few scientists in history have ranged from comets in the heavens to the lifespan of human beings with such ease. In 1720, Halley reached the pinnacle of British astronomy when he was appointed Astronomer Royal, succeeding John Flamsteed. The post placed him in charge of the Royal Observatory at Greenwich, the heart of England's astronomical research. The succession was not without drama. Halley and Flamsteed had long clashed. Flamsteed, a meticulous but stubborn astronomer, had resisted publishing his star catalogue, leading to tensions with Newton and Halley, who wanted the data for celestial calculations. At one point, Halley was even accused of publishing Flamsteed's work without permission. Their relationship was marked by rivalry, bitterness, and mutual suspicion. Yet once Flamsteed passed, Halley assumed his mantle with dignity. As Astronomer Royal, he devoted himself to improving lunar tables, vital for determining longitude at sea. He also continued his observations of comets and planetary motion, always seeking more precise predictions. Even in his 60s and 70s, Halley's energy seemed undiminished. He worked tirelessly, often at the telescope late into the night, despite the cold and the frailties of age. But who was Edmund Halley, the man? Accounts from his contemporaries paint a picture of someone different from Newton in every way. Where Newton was secretive, paranoid, and often solitary, Halley was sociable, charming, and generous. He loved conversation, enjoyed wine and tobacco, and mingled easily in society. His wit and good nature made him popular, not only among fellow scientists, but also among sailors, politicians, and even ordinary Londoners. Unlike many of his peers, Halley did not cultivate the image of the aloof philosopher. He was approachable, a man of the world. This personality was perhaps his greatest strength. It allowed him to navigate disputes, bring people together, and act as a bridge between the ivory tower of Cambridge and the bustling ports of London. Without Halley's diplomacy, Newton's genius might never have reached the public. Without Halley's curiosity, the southern stars might have remained uncharted. As Halley entered his 80s, he remained active at Greenwich, still working, still observing. His health remarkably held strong for a man of his age. In fact, he lived long enough to become one of the oldest astronomers royal in history. On the 14th of January, 1742, Edmund Halley passed away at the age of 85. He died peacefully, reportedly after calmly drinking a glass of wine. It was in some ways a fitting end for a man who had lived a full, adventurous, and convivial life. When we think of Edmund Halley today, we think first of the comet. And indeed, Halley's comet remains one of the most famous celestial objects, its periodic returns marking human generations. But Halley's true legacy is far richer. He was the man who enabled Newton, ensuring that the Principia was written, published, and preserved. He was a pioneer of exploration, who sailed across oceans to map the skies and seas. He was a visionary scientist, daring to propose bold theories even when they risked ridicule. He was a polymath, moving fluidly from astronomy to meteorology, from geophysics to demography. In short, Edmund Halley was not just a comet's namesake. He was a force of nature himself, a living reminder that science is not only about genius, but also about courage, curiosity, and the will to share knowledge with the world. Edmund Halley was born on the 8th of November, 1656, in the London district of Haggerston. England at that time was not a stable kingdom. The English Civil War, 1642-1651, had recently torn the nation apart, pitting monarchists against parliamentarians. Oliver Cromwell's Commonwealth had ruled in the aftermath, and though the monarchy was restored under Charles II in 1660, the wounds of war had not healed. Into this unsettled world came a child whose future would be tied not to politics or war, but to the heavens themselves. Halley's father, Edmund Halley Sr., was a wealthy soapmaker and landowner. His business had thrived, allowing the family to live in comfort even through London's uncertain times. This wealth was crucial. Unlike many young talents of the era who were forced into apprenticeships or clerical work, Edmund Halley had the luxury of pursuing knowledge without fear of hunger or poverty. As a boy, Halley displayed what his tutors called an unusual precocity. He mastered mathematics at an age when most children were still learning their letters. He tinkered with clocks, studied navigation instruments, and most of all, loved gazing at the night sky. London's skies were darker then, free of the glow of modern cities, and the stars shone brightly for a boy destined to chart them. At just 17 years old, Halley entered Queen's College, Oxford. Here he was exposed to the intellectual ferment of the age. The Royal Society, founded in 1660, was changing how knowledge was pursued. Experiment, evidence, and observation were replacing medieval scholasticism. The scientific method was being born. Halley fit perfectly into this new culture. He built telescopes, observed eclipses, and began to compile star charts of the Northern Hemisphere. His energy was relentless. Tutors remarked that he worked deep into the night, sometimes falling asleep at his desk with his notes scattered around him. But Halley's ambition went further. The northern skies had been studied for centuries, thanks to Tycho Brahe, Galileo, and others. The southern hemisphere, however, remained largely uncharted. If he could map those stars, he would carve his name into scientific history. And so, at the age of just 20, he made an extraordinary decision to leave England and sail across the world to a remote island in the Atlantic Ocean, St. Helena, in order to observe the heavens from the other half of the globe. The voyage to St. Helena was not for the faint of heart. In the late 17th century, ocean travel was perilous. Ships were cramped, disease spread quickly, storms were frequent, and piracy was a constant threat. Yet Halley, young and fearless, embarked on this adventure in 1676, determined to see the skies no Englishman had ever mapped. Armed with a quadrant and telescope, Halley endured the tropical humidity and fierce winds of the island. He often climbed into precarious positions to steady his instruments. Night after night he worked, sometimes under clear, dazzling skies, other times battling clouds and sudden rains. Over months of patient observation, Halley charted the positions of 341 southern stars. His dedication was extraordinary. By candlelight, he checked and rechecked his measurements. He gave new precision to constellations like Centaurus and Argo Navis, unfamiliar to European astronomers. By the time he returned to England in 1678, his Catalogus Stellarum Australium, Catalogue of Southern Stars, had earned him immediate fame. At just 22 years old, Halley was hailed as the Southern Tycho, after Tycho Brahe, the great northern star mapper. The Royal Society elected him a fellow, and King Charles II granted him a master's degree without examination. Halley had made his mark. He had shown that he was not just a gifted student, but an explorer of the cosmos. The real turning point of Halley's life, however, came in 1684 in Cambridge. By then, Halley had become fascinated with the problem of planetary motion. Johannes Kepler had described the elliptical orbits of planets, but the reason for those orbits remained unknown. Halley, along with Robert Hooke and Christopher Wren, debated the problem in London. Hooke boasted that the planets must be held by an inverse square force toward the sun, but he could produce no proof. Halley decided to consult a reclusive scholar at Cambridge, Isaac Newton. He asked Newton directly, "What curve would a planet describe if it were attracted to the sun by a force inversely proportional to the square of its distance?" Newton claimed he had already proved it years earlier, but had misplaced the paper. Encouraged by Halley, Newton reworked the problem and soon expanded it into a grand treatise that would become the Principia Mathematica. It was Halley who urged Newton to keep writing, Halley who managed the editing, and Halley who paid for the printing out of his own pocket when the Royal Society could not. Without Edmund Halley, the Principia, the book that unified heaven and earth under the law of gravitation, might never have been published. Though Halley's name will forever be linked to his comet, few realized the audacity of his discovery. In the late 17th century, comets were mysterious, feared, and unpredictable. Halley studied records of comets from 1,531, 1,607, and 1,682. He noticed their orbits were strikingly similar. Using Newton's laws, he proposed something revolutionary. They were not three comets at all, but the same comet returning on a cycle of about 76 years. In 1705, Halley published his prediction that the comet would return in 1758. He admitted he would not live to see it, but posterity would judge him. Sure enough, on Christmas night of 1758, 16 years after Halley's death, the comet returned exactly as he predicted. The world remembered, and the comet was christened Halley's Comet. It was the first time a comet had been shown to be a recurring celestial body bound by gravity, not a random apparition. Halley had domesticated the terror of the heavens. By the early 1682, Edmund Halley was no longer the young prodigy returning from St. Helena. He had matured into a respected fellow of the Royal Society, a man deeply enmeshed in the intellectual and social networks that defined England's scientific revolution. London in this period was a city of contrasts. The Great Fire of 1666 was still a living memory, its scars etched into the rebuilt streets. Trade was booming, ships from across the globe filled the Thames, and with them came new knowledge, exotic plants, astronomical instruments, maps of distant lands. The Royal Society met regularly, a gathering place for gentlemen, clergymen, and natural philosophers alike. Halley fit seamlessly into this world. Unlike Isaac Newton, who lived in isolation and suspicion, Halley was a man of society. He enjoyed conversation, laughter, and debate. He was equally comfortable in the company of scholars, sailors, or statesmen. This sociability would serve him well as he built alliances across science, politics, and navigation. During these decades, Halley pursued a remarkable range of inquiries. He published studies on barometers and air pressure, speculating on the structure of the atmosphere. He investigated the motion of the moon, a problem of critical importance for navigation at sea. He wrote papers on the causes of winds, linking them to solar heating of the Earth, a pioneering step in meteorology. He even dabbled in chronology, attempting to use eclipses to date historical events. His intellectual curiosity was boundless, but what defined him most was his ability to move between theory and practice, to connect the lofty mathematics of Newton with the gritty needs of sailors navigating the oceans. In 1705, Halley published his most famous prediction, that the comet seen in 1682 would return in 1758. The idea electrified the scientific community. For centuries, comets had been seen as random, divine portents. If Halley was right, it meant comets were natural, predictable bodies, subject to Newton's laws. But not everyone accepted his claim. Some scoffed that it was impossible to forecast such a thing. Others accused him of arrogance, daring to impose mathematical certainty on the mysteries of heaven. Halley himself was modest about it. He wrote, "I may venture to foretell that this comet will return again in the year 1758. If it should then appear, candid posterity will not refuse to acknowledge that this was first discovered by an Englishman." He was right. When the comet returned, the world remembered his bold prediction. Though Halley did not live to see it, his name became immortal. Before the comet secured his immortality, Halley had undertaken a different kind of adventure, one that showed his courage as much as his intellect. In 1698, he was given command of the Paramour, a small vessel of the Royal Navy. His mission, to survey the magnetic variations of the Atlantic Ocean. At the time, sailors relied on compasses, but Earth's magnetic field was irregular. Halley hoped to chart these variations systematically, producing maps that would improve navigation. For a scholar to command a ship was extraordinary. Halley had to learn the duties of a captain, enforce discipline, and navigate not only the seas but also the tempers of his crew. The first voyage was marred by quarrels with officers at one point. Halley had to court-martial his lieutenant, yet he pressed on. On his second voyage, he succeeded in gathering enough data to publish the world's first isogonic chart, a map showing lines of equal magnetic variation. This was a practical triumph. It gave sailors a new way to correct their courses, reducing the risks of long-distance voyages. Halley was praised not only as a scientist, but as a man of action. Few natural philosophers of his age could boast of both publishing papers in the Royal Society and commanding a ship across the Atlantic. In 1692, Halley presented one of his most imaginative and controversial theories to the Royal Society, the hollow Earth hypothesis. He suggested that Earth might consist of a hollow shell about 500 miles thick, with two inner concentric shells and a solid core. These layers, he argued, might each have their own magnetic poles, accounting for the irregular behavior of compasses. Halley even speculated that the inner worlds might be habitable, perhaps even populated, with light reaching them through openings at the poles. Modern science has long discarded this theory, but at the time it was a bold attempt to explain real mysteries. Halley was not afraid to risk ridicule, to put forward a daring hypothesis. In this, he embodied the experimental spirit of the Royal Society. Better to propose and test than to remain silent. Halley's career was not without conflict. His relationship with John Flamsteed, the first astronomer royal, was notoriously bitter. Flamsteed was meticulous, but slow, hoarding his star catalog rather than publishing it. Newton, eager for the data to refine his lunar theories, grew frustrated. Halley sided with Newton, eventually publishing Flamsteed's work against his wishes. Flamsteed never forgave him, calling him the plague of my life. Despite the feud, Halley's reputation only grew. By 1720, when Flamsteed died, Halley was appointed the second Astronomer Royal. He now directed the Royal Observatory at Greenwich, the crown jewel of English astronomy. At Greenwich, Halley devoted himself to improving lunar tables, which were essential for calculating longitude at sea. He observed tirelessly, even into his 70s, producing data that would serve navigators for generations. In 1720, Edmund Halley was appointed the second Astronomer Royal of England, succeeding his old rival John Flamsteed. For Halley, now in his 60s, it was both a triumph and a heavy responsibility. The Royal Observatory at Greenwich, founded in 1675, was the heart of English astronomy. Its purpose was practical as much as theoretical, to improve navigation at sea, to chart the stars and the moon so sailors could find their longitude. For a maritime empire like Britain, astronomy was not just a science, it was a matter of national power. Halley threw himself into the work. Despite his age, he began a program of long-term lunar observations designed to refine the moon's motion tables. The problem of longitude was one of the greatest challenges of the age, and Halley believed careful, systematic study of the moon's orbit was the key. Night after night, through the damp chill of English winters, he observed, recording positions with painstaking care. But Halley's role at Greenwich was not only about the stars. He was also an administrator, a public figure, and a symbol of English science. Visitors came to Greenwich to meet the famous Astronomer Royal. Scholars consulted him, sailors sought his advice, and the Royal Navy relied on his charts. For 2 decades, Halley served not just as a scientist, but as a steward of England's astronomical future. By the 1722nd and 1732nd, Halley was a man of advanced age, but his energy seemed inexhaustible. Where others might have retired into comfort, he continued to work late nights at the telescope, despite failing eyesight and the stiffness of old age. Contemporaries remarked on his cheerful temperament. Unlike Newton, who grew increasingly bitter and reclusive in old age, Halley remained sociable. He still enjoyed wine, tobacco, and conversation. He still laughed easily. Even in his 70s, he could be found in animated discussions about astronomy, magnetism, or the politics of the Royal Society. One of his continuing interests was cometary motion. Though his prediction of the great comet's return in 1758 was behind him, Halley continued to calculate orbits and refine his understanding of these celestial wanderers. He also revisited his earlier studies on climate and winds, pondering the balance of forces that shaped the Earth's atmosphere. But his greatest commitment remained to the moon. Determined to improve the lunar tables, Halley persevered in his nightly observations, slowly building the data that would help navigators far beyond his own lifetime. By the mid-1732nd, Halley was in his late 70s. Few men of his generation lived so long, let alone remained active in science. He had outlived many of his contemporaries, Robert Hooke, Christopher Wren, John Flamsteed, even Isaac Newton, who died in 1727. Newton's death marked the end of an era. The great mathematician had been Halley's friend, collaborator, and at times rival. With Newton gone, Halley stood almost alone as one of the last giants of the scientific revolution's first generation. The younger scientists now looked to him as a living legend. His comet prediction was remembered, his role in the Principia admired, his voyages at sea retold as stories of adventure. But for Halley, these were memories. His life was now devoted to the steady, quiet labor of observation. Time, however, was catching him. His eyesight weakened, his hand trembled more as he wrote, and his once tireless body grew frail. Yet he refused to stop. Even in his 80s, he continued to climb to the observatory dome, a figure of determination against the night sky. Between 1739 and 1741, Halley made what would be his final series of systematic lunar observations. By then he was over 80 years old, nearly blind, and weakened by age. Assistants sometimes helped him, but he insisted on doing as much as he could himself. These observations, though unfinished, contributed to the body of data that later astronomers would use to refine the lunar theory. In a sense, Halley was laying groundwork for a future he would never see. On the 14th of January, 1742, Edmund Halley died at the age of 85. According to accounts, he passed away peacefully at Greenwich after calmly drinking a glass of wine. He left no dramatic last words, no tortured struggle, only a quiet end to a long, full, and fearless life. Edmund Halley's death did not pass unnoticed. He was remembered as the man who gave his name to the comet, but also as something greater, the enabler of Newton. Without Halley, the Principia might never have been published. It was Halley's encouragement, editing, and financing that brought Newton's laws of gravitation to the world. The explorer of the skies. His Southern Star Catalog opened a new hemisphere to astronomy, the navigator's ally. His magnetic charts and lunar observations laid foundations for safer sea voyages. The visionary, even his mistaken ideas, like the hollow Earth, reflected a willingness to push boundaries and imagine boldly. The character, unlike many of his more austere contemporaries, Halley lived with warmth, humor, and sociability. He was a man of science who also loved life. Today, when Halley's comet blazes across the sky once every 76 years, it carries with it the story of a man who dared to see beyond the horizon, who bridged theory and practice, who supported genius and was a genius himself. For most people, Halley's name is tied only to the comet. But for those who look deeper, his life is a reminder that science is not built by solitary figures alone, but by networks of friends, patrons, explorers, and dreamers. And in that network, Edmund Halley shone as brightly as any star. When Edmund Halley assumed the position of Astronomer Royal in 1720, he was 64 years old, a venerable age for the time. Yet far from slowing down, he approached the post with the same vigor that had carried him across the Atlantic decades earlier. The Royal Observatory at Greenwich was not just a workplace, it was a symbol of England's aspirations as a maritime and scientific power. Founded by Charles II in 1675, its mission was practical, to perfect astronomy for navigation. In an age when ships connected the world, the ability to determine longitude at sea meant the difference between profit and disaster, empire and ruin. Halley inherited an institution marked by controversy. His predecessor, John Flamsteed, had been brilliant, but notoriously slow to publish his data. His reluctance to share his star catalog had angered both Newton and Halley, leading to bitter disputes. When Flamsteed died in 1719, the observatory passed into Halley's hands. For some, it was poetic justice. The man who had once published Flamsteed's catalog against his will now sat in his chair. The 1,722nd for Halley were a time of consolidation and vision. He reorganized the observatory, encouraged younger astronomers, and set long-term projects in motion. His primary focus was the moon, whose complex motion, he believed, held the key to solving longitude. Night after night, Halley worked at the telescope, recording lunar positions with meticulous care. Sometimes his daughters or assistants helped him, but often he worked alone, a solitary figure in the observatory dome, wrapped in heavy coats against the chill of English winters. The image is striking. An elderly man, hair silver, eyes still sharp, peering through the eyepiece into the heavens he had charted since youth. Though Newton had died in 1727, his presence still loomed large over Halley's later years. The two men had been bound by friendship, tension, and mutual respect. Newton, buried with grandeur at Westminster Abbey, was celebrated as the greatest genius of his age. Halley, meanwhile, worked quietly at Greenwich, his achievements less glamorous but equally vital. The contrast between them is telling. Newton was secretive, solitary, and jealous of rival. Halley was sociable, open, and generous. Newton's legacy was monumental, But it was Halley who had made Newton's work possible, financing the Principia and managing its publication. As the 1722nd unfolded, younger scientists recognized this. Some even whispered that Halley's true greatness lay not only in his discoveries, but in his ability to support, connect, and enable others. In this sense, Halley was a rare figure, a genius in his own right, yet also the midwife of another's genius. History often celebrates the solitary thinker, but Halley's life showed that collaboration and friendship can be just as world-changing. By the 1732nd, Halley was in his 70s. Most men of his generation had long been in their graves. Yet Halley remained vigorous, walking the halls of Greenwich with energy, his presence commanding respect. Visitors often described him as cheerful and engaging. He loved conversation and did not withdraw into the bitterness of age. Students and travelers alike sought him out, eager to meet the man who had predicted the return of a comet and sailed across the seas in the name of science. His work in this decade focused relentlessly on the moon. Determined to improve the accuracy of lunar tables, Halley persisted with nightly observations, sometimes dictating notes when his hands grew too unsteady. These records, though imperfect, provided valuable data for future astronomers like Tobias Mayer and eventually for the solution to the longitude problem. Outside the observatory, Halley's reputation grew. The Royal Navy valued his magnetic charts. Merchants praised his contributions to navigation. Insurance companies quietly relied on the actuarial methods he had pioneered decades earlier. Halley was, in effect, a scientist whose work reached every corner of English society. Yet even as Halley's fame spread, he could not escape the weight of years. His eyesight dimmed, his body slowed. He often required assistance climbing the observatory stairs. Still, he refused to abandon his work. By the late 1732nd, Halley was one of the last living links to the founding era of the Royal Society. Hooke was gone, Wren was gone, Newton was gone. Halley stood alone, a survivor of the great generation that had launched the scientific revolution in England. Younger astronomers treated him with reverence. For them, he was not merely a man, but a living relic, a reminder of the daring spirit that had carried science from speculation into modernity. It was in these years that Halley reflected most deeply on his comet prediction. He knew he would not live to see its return in 1758, yet he spoke of it with calm certainty. Posterity, he said, would judge him, and indeed it would. In the early 1742nd, Halley was well into his 80s. Few men in England lived so long, and fewer still remained active. He made his last systematic lunar observations between 1739 and 1741, sometimes dictating numbers to assistants when his vision failed. On the 14th of January, 1742, Edmund Halley died at the age of 85 in his house at Greenwich. According to those present, he drank a glass of wine shortly before passing, as calmly as if he were going to sleep. It was a fitting end for a man who had lived with balance, humor, and fearless curiosity. Halley's death closed a chapter in English science, but his legacy was immense. He was remembered for Halley's comet, the celestial visitor he immortalized. His role in Newton's Principia, without which the laws of gravity might have remained unpublished. His Southern Star Catalogue, the foundation for later astronomical work in the Southern Hemisphere, his magnetic charts, essential for navigation, his pioneering work in actuarial science, the quiet beginnings of life insurance, his warmth, generosity, and sociability, so rare among scientific geniuses. Every 76 years, when Halley's comet streaks across the sky, it is not only a spectacle of nature, but also a reminder of the man who dared to predict its return and whose life shone with the same brilliance. Though Edmund Halley left the world in 1742 as a celebrated astronomer royal, one must always return to his beginnings to see the arc of his journey. Born in a time of civil war, nurtured by a father's wealth, Halley's childhood was one of opportunity. His earliest lessons in arithmetic and astronomy set the foundation for everything that followed. Even late in life, Halley spoke fondly of his boyhood nights gazing at the stars. He would recall how London skies, free of the smog of industry, glittered with constellations. To the young boy, they were not simply points of light, they were mysteries waiting to be solved. His destiny, in some sense, was written overhead. At Oxford, Halley's life accelerated. Surrounded by mentors and peers, he absorbed the ferment of new ideas. The Royal Society, founded when he was still a boy, had become a beacon for experimental philosophy. Bacon's call for empirical observation echoed in the lecture halls. Halley thrived in this environment. He was not content to remain a passive student. He bought instruments, built telescopes, and sought out every opportunity to observe. His professors quickly realized they had in their midst a prodigy who might rival the great minds of Europe. Halley's voyage to St. Helena in 1676 was his great leap into history. To leave England at 20, sail into the unknown, and endure harsh conditions for the sake of science was extraordinary. The catalog of 341 southern stars he produced was more than data. It was a chart of the unknown, a gift to Europe, and a personal declaration that Halley was not just a scholar, but an explorer. When he returned to England, he was hailed as the Southern Tycho, a title that announced his arrival on the world stage. Perhaps no moment in Halley's life shines brighter than his encounter with Isaac Newton. The year 1684 was a hinge of history. Newton had the proof of gravity, but he had neither the inclination nor the resources to publish it. Halley supplied both. It was Halley who visited Cambridge, asked the right question, and unlocked Newton's genius. It was Halley who edited the Principia, calmed Newton's disputes, and paid for the printing himself. Without Halley, there may have been no Principia. Without the Principia, the scientific revolution might have limped forward without its grand unifying text. Halley's role here cannot be overstated. He was the enabler of one of the greatest works in human history. The prediction of Halley's comet was a masterpiece of scientific daring. To scour the records of centuries, apply Newton's laws, and declare that a comet would return in 1758, long after his death, was to place faith in reason over superstition. When the comet returned as he had foretold, it secured his immortality. Every 76 years, humanity looks up at the streak of light and remembers his name. Few scientists achieve such an enduring link between personal identity and cosmic wonder. Halley's naval voyages and magnetic charts were more than scientific exercises, they were tools of empire. The British Navy relied on such data to cross the Atlantic, to dominate trade routes, and to expand its influence. Halley's isogonic chart, showing lines of equal magnetic variation, was revolutionary. For sailors who had long relied on dead reckoning and uncertain compasses, his work was a light in the darkness. He was not a cloistered scholar. He was a man who risked the sea to bring knowledge home. His appointment in 1720 as Astronomer Royal was the crowning achievement of a lifetime. At Greenwich, Halley presided not only as a scientist, but as a symbol of England's intellectual strength. Even in his 60s and 70s, he worked tirelessly. His lunar observations, though arduous, laid the groundwork for the eventual solution to the longitude problem, one of the greatest scientific challenges of the age. The 1732nd and early 1742nd were Halley's long twilight. Surrounded by the ghosts of his generation, he lived on as a cheerful survivor. Where Newton had grown cold and suspicious, Halley remained warm and approachable. He entertained visitors, mentored the young, and kept watch over the heavens until his body could no longer follow his will. On the 14th of January, 1742, he died with dignity, a glass of wine in hand. It was the peaceful end of a man who had lived not only brilliantly, but joyfully. When Edmund Halley died in January of 1742, he could not have known the full weight of the legacy he left behind. He could not have seen the comet blaze across the night sky in 1758 to vindicate his bold prediction, nor could he have imagined that every 76 years human beings across the globe would look up in awe and whisper his name. Yet his life was never about certainty of fame. It was about curiosity, about risk, about stepping beyond the familiar to chase the unknown. Halley was, in many ways, a paradox. He was not as mathematically brilliant as Newton, yet without him Newton's most important work might never have seen the light of day. He proposed wild theories like the hollow earth, but he also gave the world one of the most precise star catalogues of his time. He loved society, conversation, and laughter, even as he dedicated countless solitary nights to the slow, meticulous work of observation. He was at once a dreamer and a pragmatist, a friend of sailors and a companion of philosophers. The comet that bears his name is only the most visible fragment of his story. Behind it lies a man who sailed dangerous seas to chart the heavens, who bridged the gap between theory and practice, who dared to imagine worlds within worlds. He was not afraid to be wrong, because he understood that the act of asking questions, of venturing into the unknown, was itself the lifeblood of discovery. And perhaps that is the true measure of Halley's greatness. Not that he was always right, nor that he stood alone in brilliance, but that he embodied the restless spirit of inquiry. He supported others when their genius needed a hand. He offered bold speculations when mysteries demanded imagination, and he turned his gaze outward toward the stars, the seas, the winds, the very fabric of earth itself, seeking patterns where others saw only chaos. Even now, centuries later, Halley's example speaks to us. In an age where we often seek certainty, where we hunger for final answers, Halley's life reminds us that science is not a closed book, but a continuing story. There are always new stars to map, new forces to understand, new voyages to undertake. The comet returns, yes, but each generation sees it differently. To some, it is a wonder, to others, a calculation fulfilled, and to still others, a mystery not yet solved. And so, the story of Edmund Halley does not truly end with his death in Greenwich in 1742. It lingers in every astronomer who points a telescope skyward, in every navigator who charts a safe course across the seas, in every scientist who dares to imagine a theory that seems impossible until time proves it true. The question is not only how Halley changed his world, but how his restless spirit might change ours. When the comet next returns, streaking across the heavens, as Halley foretold, what questions will we ask? What mysteries will we chase? And who among us will have the courage, like Halley, to follow curiosity wherever it leads?